Right, we were going to look at algebra today.
Yes.
I'm going to start with expressions because that's the first thing that you do in algebra. So we'll just look at expressions. And this is going to be simply a case of collecting together like terms. So when I say like terms, it must have the following. The same variable. Now the variable is the letter, so it's either an x or a y or whatever. So it has to have the same variable and it has to have the same power or the same indice. That's what determines that it's a like term. So what they're going to do is they're going to give you expressions and they're going to say simplify. And they'll give you something like 3 plus 2x plus 5 plus 4x. They'll give you something like that. And you're expected to simplify that. All right. Now, in order to simplify that, you've basically got to, what they're telling you to do is they're telling you to get your terms that are the same, your like terms, and add them together. So the like terms here, I've got a 3 and a 5. They like terms because they're both variables. So I take my 3 and my 5 and I add those together, right?
Yeah.
So 3 plus 5 is 8. Good. And then I collect my x's together. So my 2x plus my 4x. And if I have 2 x's and I add another 4 x's, then I've got 6 x's. And that would be my final answer. That's it. I can't add any further because the 8 and the 6x aren't like terms because they don't have the same variable. You can only add and subtract terms if they are like terms. So the first thing you're going to be looking at is you're going to be looking at stuff like this where you're simplifying expressions to get your terms the same. The other thing they might do is they might give you something like this. They might say 2x squared plus 8x plus x squared minus 4x plus 5. They might give you something really long like that they say to you, you've got to simplify. So I'll start with the x squareds. I've got a 2x squared and I've got an x squared. So if I've got 2x squareds there, plus a single x squared there, and I add those together. So I can group them together first. You don't have to do this. I just do it so it looks more obvious what I'm doing. That's going to end me up with 3x squareds. So 2x squared plus another x squared. I've now got 3x squareds.
3x squared there.
If I look at just the x's, I've got an 8x minus 4x. Well, 8 minus 4 I know is 4, so I'm going to have 4x left. And then tagging on the end was a plus 5, but the plus 5 doesn't have any x's at all, so that's going to be plus 5. And then that is my final answer. I can't go any further than that because none of the other terms in this expression have got an x squared and none of the others have an x, so they aren't like terms. Because remember, like term has to have the same variable, in other words an x, and the same power. My first term has a power of 2, but none of the others have a power of 2, so they're not like terms.
Exactly, yeah.
Cool. Then you're going to have to do, so that's adding and subtracting of algebra and expressions. You're going to have to possibly do some multiplying. Now multiplying, they'll do firstly some easy stuff, like they'll say take 3 and you might have x plus 4, something easy like that.
Okay.
If you're multiplying expressions, whatever's outside the bracket has to be multiplied by everything that's inside the bracket. So I've got to say that that'll be, and I'm going to do a step you don't have to do. I'm going to write 3 times x plus 3 times 4. Now you don't have to do this step. You can just go straight into saying 3 times x is 3x plus 3 times 4 is 12. And that's yours. Arabella. you want to say hello to
That's
Annie?
not difficult.
One of my students coming to say goodbye. This is Arabella. Stick your face past the camera, then
Hello.
Annie can see you. There you go.
Yeah.
Have a good afternoon, Bella. See you tomorrow. So that then I'm finished with that. I can't add the 3x and the 12, obviously, because they, again, are not like terms. But I've just multiplied the 3 by each term inside the bracket.
Okay.
They will make these a little bit more difficult for you by doing an expression times an expression, where they'll do a binomial, what we call a binomial. So you might get x plus 4, and you might say times 3x minus 5, maybe. I'm just making stuff up as I go along. So what you've got to do, remember I said everything outside the bracket must be multiplied by everything inside the bracket. In this case, I have two things in the first bracket that are going to have to be multiplied by two things in the second bracket. So I start with the x. And so I'm going to take the x, I'm going to multiply it by the 3x. And then after that, I'm going to multiply it by the minus 5 as well. So then my x times my 3x will be 3x squared. And then the x times the minus 5 is just going to give me minus 5x. I'm now finished. I've multiplied the x by the 3x and by the minus 5. So I'm done with...
And I do the same with 4.
Then I do exactly the same with 4. Good. 4 times the 3x and 4 times the minus 5. So the 4 times the 3x, it's a positive 4 and a positive 3, so it's plus 12x. And then I've got a positive 4 times a minus 5. Well, a positive times a negative is always negative. And 4 times 5 is 20. Do you see I now have 4 terms? Because I had 2 terms times 2 terms. So I've got 4 terms. But the middle 2 terms usually, when you've got a binomial times a binomial, will usually have the same variable and the same power. I have only got one term with an x squared in it. That's my 3x squared. So that just stays 3x squared. That won't change at all. But my minus 5x plus 12, well, if I'm taking a minus 5 and adding 12 to it. So if I was on, say I was on a number line, just quickly pulling up a number line here. Let me just get a nice straight line. So if I was on a number line, I'm saying I'm starting at minus 5, and then I'm going to add 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because whenever we add, we go to the right. Will take me minus 5, minus 4. Yes, good. It'll take me to the 7, because I'm going to go all the way up. 1, 2, 3, 4, 5. There's the 0, and then another 7. So yes, so minus 5 plus 12 would give me a plus 7x. Good, well done, Annie. You got that straight away. And then the minus 20 is still tagged on the end. The only two I can work with once I get my 4 terms are the 2 middle terms, because they're the only ones with the x that has a single power. And then again, then I'm finished, because I only have one variable that's got a power of 2. I've got another variable over here behind the 7, but I don't have any variables on the 20. The 20 is just a constant. It's just a number.
Yes, thank you. I'm just quickly going to see if I can record it on my phone too. I'm quickly going to try and figure that out.
Okay.
Let me just see screen rename. No, that's definitely not it. Why can't I know there's a setting where you can screen record. I just don't know where it is now. Let me quickly go to my settings just so I can screen record or
Yeah, no problem. I was trying to do it on the Google Meet app, because it's got a thing that says to record, but then it tells me I have to subscribe, and it's so many dollars a month and all that to record. So I thought, let me just do it on my phone.
yeah, those ones you did on your phone, can you maybe please just send them to me so I can just go through our lessons again?
Yes,
I
absolutely.
I can't possibly remember everything, so that would really help a lot. And as I said, I can't figure out now where to find it, but I'll go look again after the session. But will you please then just in the meantime send me the ones that you record it with your phone, please.
I will do that.
Thank you so much.
With algebra, sometimes they're going to also give you dividing, but they'll do it in the form of a fraction. So they'll do something like 4x to the power, let's just say 8y to the power 3 over 12 x to the 3 y to the 7, maybe. They'll do something like that.
Yeah, these are the ones I've struggled with.
Now, with these ones, I'm going to just change the color quickly to do the simplifying in color. What I can do with the numbers is I look for a common factor of 4 and 12. Now, 4 goes into 4 and into 12. So I can do my golden rule of fractions, which is whatever you do at the top, you do at the bottom. And I can divide the top and the bottom by 4. And that will simplify at least the numbers. I'm just going to do this one step at a time, but obviously when you're doing this in a test, you can do it all in one step. So that leaves me with 4 divided by 4 is 1. I never write a 1 in front of variables in algebra. So I'm just going to leave it as x to the power 8, y to the power 3. I know there's an invisible 1 in front of that x to the power 8. And then 12 divided by 4 is 3, so I'm left with 3x to the power 3. Y to the power 7. Oh my goodness, that 3 doesn't look very good. It just looks like a blob. And then y to the 7. There we go. Now what I've got to do is I've got to sort out my variables. The thing with your variables is whichever one has the highest power, that's going to be the one where your variables will remain. So can you see x to the 8 has a higher power than x to the power 3. So I'm going to end up with x's at the top in the numerator. But with my y's, can you see y to the 7 is bigger than y to the 3? So my y's will, the y's will end up in the denominator. When you're dividing powers, you subtract the power. So anytime you're dividing powers, you just subtract them. So my x to the 8, I'm going to write as if I'm subtracting it. So you can see I'm just going to say x to the 8 minus the 3. That's subtracting the power 3 at the bottom. At the bottom, I've still got my 3. I won't write the x's because by writing the minus 3 behind the 8, I've actually worked the x to the power 3 at the bottom into the numerator. I also don't worry about writing y's in the numerator. Now just go down and write y's in the denominator. And I'm going to have my y to the 7, which was already at the denominator.
Yes.
Minus the 3 that was there.
I'm just putting my phone on charge and this thing.
No worries.
There we go.
Got it.
Okay.
So what I've done is I've taken that 3 as the power of the x and the 3 in the denominator and just subtracted it from the power 8 in the numerator. And I've taken the 3, the power of the y in the numerator, and subtracted it from the 7, the power of the y in the denominator. And that will leave me with a final answer then of 8 minus 3 is 5, so I'll have x to the 5 in the numerator.
I'm so sorry to ask, can you just quickly explain that one again, because you lost me.
Okay,
so I had to get the charger now, so I lost focus a bit.
Yeah, no, that's
fine.
fine.
Just explain that one again.
Okay, so sorry from the beginning. When I had 4x to the 8, y to the 3 over 12x to the 3, y to the 7, the first thing I did is I sorted out the coefficients, the 4 and the 12.
Yeah.
4 and 12 have a common factor of 4. So I just divided
by 4.
Divided the top and the bottom by 4. So 4 divided by 4 is 1. I don't write 1x to the power 8 because I know that if I don't write a number in front of the x, it means there's a 1 there. And then the 12 divided by 4 gave me a 3. So I'm left with x to the 8, y to the 3 over 3 x to the 3, y to the 7. So I haven't done anything to the powers of the variables yet. I've just left the powers of the variables the same for now.
Okay.
I'm now dividing x to the 8 by x to the power 3. Now when you're dividing with powers, you actually subtract the powers. That's from that rule where if I had a to the m divided by a to the n, it equals a to the m minus n. That's one of my laws of powers. I'm going to use that law now. So instead of having x to the 8 over x to the 3, I'm going to say x to the 8 minus 3 is the same as x to the 8 over x to the 3. I just subtract the power, the smaller power from the bigger power.
The smaller power from the bigger power, okay.
And
so you're going to say 12 minus 4.
No, that I'm finished with the 12 and the 4. That's just a normal, straightforward, that's just like a normal fraction where you would have simplified that by dividing the top and the bottom by the same number. So I'm talking now about the 8 and the 3 as being the powers of the x. Can you see the x at the numerator x had a power 8, the denominator x had a power 3. Okay. So to sort my x's out, I'm just going to say at the top x to the power of 8 minus 3. And that's how I divide the x to the 8 by the x to the 3.
Okay, so you're going to say 8 minus 3, okay.
Then with the y's, I've left the y's at the bottom because the bigger exponent was at the bottom. Y to the 7 is bigger than y to the 3, but I'm going to do the same thing. I'm going to say y to the power 7 minus 3 because I'm now subtracting that 3 from that 7.
3, that's okay, and then you're going to say the 8 minus the...
8 minus the 3 is 5, so I get x to the 5 at the top.
But why are you only minusing one of them and not both of them?
No, I did. I took the 7 minus 3 at the bottom and left me with y to the power 4.
And the 8 and the other one?
The 8 minus 3 gave me a 5.
Oh, okay, I understand. Never mind.
And the 7 minus 3 gave me a 4.
The answer is, quickly go up, please. Okay, so the answer is going to be x 8 3 y over 3 x 5 x 7 8 minus 3 equals x 3y 7 minus, what is that? 7 minus?
7 minus 3.
7 minus 3.
Yeah.
Okay, and that gives you?
And that will give me x to the 5, because 8 minus 3 is 5. The 3 is still sitting in front because the 3 is now just my coefficient. And then the 7 minus 3 is 4. So it gives me x to the 5, y to the 4.
Okay, perfect.
Let me do another similar one first before we go into the more complicated stuff. So you might get something like this. You might get, I'm just going to do now, if I had x to the power, let's just say 9, divided by x to the power 4. If I just had that.
X to the power 9 divided by x to the power 4, okay?
Can you see that my bigger power is at the top, right? Because 9 is bigger than 4. So then I just write that as x to the 9 minus 4. And that would give me x to the power 5.
Okay, that will give you...
So when you're dividing powers, you're just going to be subtracting one power from the other, if the bases are the same.
Okay, and if it was the other way around,
let's say it was x4 over x9. Let's say it was the other way around. Then I'd have to keep my x's at the bottom in the denominator. And to do that, I'd have to replace the x to the 4 with a 1, and I'd do my x to the 9 minus 4 at the bottom, and then that would be 1 over x to the power 5.
Okay, so that would be over x to 5. Okay, cool.
Okay, oh, excuse me. All right, what do we do then if we are, dividing our powers, we have to subtract. If I'm multiplying powers, what if I had, for example, x to the 7 times x to the 3. Well, I've seen if I'm dividing my powers, I subtract the powers. If I'm multiplying my powers, I add them. So that would be x to the 7 plus 3.
I just want to write that down.
Sure.
Okay.
And then 7 plus 3 is just 10.
It's just 10. Okay. X10.
And then if there's numbers in front, we always work with the coefficients separately. So let's say you had 2x to the 3 times 3x to the 4. Your coefficients still work like a normal multiplication.
Okay.
So the coefficient, the 2 and the 3, you'd still multiply together. So you'd still have 2 times 3 is 6. And your x to the 3 plus 4. So when you get to the variables, you're going to use the rule that says, well, if you're multiplying powers, you add the powers. So you still multiply your coefficients like you would ordinarily. That doesn't change at all. It's just the differences now when you've got your powers, you have to add them. And so your final answer...
That would be 6x7.
Good, 6x7. Good, that's exactly what your answer would be.
Okay.
So we've done dividing powers, we've done multiplying powers. The only other thing you have to know with powers, well, there is another thing. Anything to the power 0 is 1. Anything to the power 0 is always 1. So if you see that power 0, it's 1. Even if it's 3,246,124, all to the power 0, it's still 1. It doesn't matter how big the number is. It doesn't matter what they're doing. If it's to the power 0, it's going to be 1 all the time. Then we get what they call raising a power to a power. So let's say I had 3x to the power 4, and I raised that to the power 3. So I put a power outside a bracket. I'm going to raise everything in that power to that. Well, the first thing I'm going to do, this is called, power 3 is called cubing. So the first thing I'm going to cube is the 3. I'm going to say 3 cubed x to the, and with your powers, when you're raising a power to a power, you now multiply your powers.
Okay.
3 cubed is 3 times 3 times 3. And 3 times 3 is 9, and times 3 again is 27. So 3 cubed would give you 27. And then your power would be x to the 4 times 3, which is just the power of 12. So your answer there would be 3x to the power 12.
3x to the power 12. Okay.
Sorry, not 3, sorry, 27x to the 12.
7, I was about to be like
so anytime you're raising a power, and it can be, you could have something like 2x to the 3, y to the 4, all raised to the power 2. So you could do that. Then you'd have your 2 to the power 2, x to the 2 times 3, y to the 2 times 4. See what I've done? I've the 2, I straight away just put that as whatever power is outside. So whatever your coefficient is, the number in front, you're just going to, if like earlier we cubed it, now we're squaring it. 2 to the power 2 is just 2 times 2, which is 4. X to the 2 times 3 is x to the 6. So you see I just took the 2 and multiplied it by the 3.
Is that 2 times 3 and 2 times 4? I just want to make sure.
And 2 times 4, yes.
But why is it times now and not plus? Because I thought multiplying is plus and dividing is minus.
And you are right. Multiplying is plus and dividing is minus. But we're not multiplying or dividing now. We're raising a power to a power.
Oh, okay.
So we've taken this whole bracket, everything, and raised it to the power 2.
Okay.
So when we're raising a power to a power, we multiply.
Okay.
Then what they did in one of the exams is they put a really nasty question where they did a bit of dividing and raising a power to a power just to see if you'd be able to cope with that. So the exam question went like this. They had 4x cubed y to the 4 z over, so here's your dividing coming in.
This is the difficult one.
This is the one they put in the exam, yes. 8x to the minus 5, they gave a negative exponent. Y to the 3, z to the minus 2. So they now really were giving you horrible exponents. And then they still said, well, let's raise that to the power 2. So this was the question that they put in an exam, in a GED exam.
Yeah.
Now remember what I said, we'll do the coefficients first. So if I look at the coefficients, I can divide the top and the bottom by 4. So I'm going to divide the top and the bottom by 4 just to simplify the 4 over 8 to make that an easier number. Then I don't have to work with a 4 and an 8. So that would give me, I'm not going to do anything else in the first step, I'm just going to do that. 4 divided by 4 is 1, so I'm going to just cancel the 4 out completely, and so I'm now left with x cubed y to the 4 z. So you see I haven't changed anything with the variables.
Yeah.
8 divided by 4 is 2, so I'm going to put my coefficient there of 2. X to the minus 5, y to the 3, z to the minus 2, all raised to the power 2. Now, as you correctly said earlier, when I'm dividing, I'm minus. And I'm going to use the same rule I used earlier. The power with the biggest, the letter with the biggest power, I'm going to leave it where it is. If it's at the top of the fraction, I'm going to leave it at the top. If it's at the bottom, I'm going to leave it at the bottom. So starting with, I'm just going to put my 2 there because it was sitting there quite happily. Starting with the x. 3 is bigger than minus 5, right?
Yeah.
So what I'm going to do is I'm going to say x to the 3 minus 5. Because remember, we're dividing, so we're subtracting, the same as we did earlier.
When x to the 3 minus 5.
Minus 5, because remember, that's a minus 5 at the bottom. So I'm going
Wait,
to...
how did you get that 3 minus 5?
So I took the 3 that's at the top there,
Yeah.
and I subtracted this 5 that's at the bottom.
Okay.
And when you're subtracting a negative, so I'm saying minus a minus, remember that's going to make it a plus in the end. Because a minus and a minus is a plus.
Plus.
Yeah.
So then what?
So that will become, in the next step, that'll become 3 plus 5.
Okay. So x 2, okay, and then?
Going on to the y's. 4 is bigger than 3, right?
4 is bigger than 3, yes.
So I'm going to keep the y's at the top as well, because y to the 4 is at the top, and I'm going to make that 4 minus 3. So now I've taken this 4 that's with the y, and I've subtracted that 3 that's at the bottom.
Okay, what 3? Because we've already said 3 minus 5, so which 3 is that now?
That's this 3 at the bottom here by the y. So I've taken this 4, the 4 that's the power of the y at the top, and I've subtracted the 3 that's with the y at the bottom.
Okay, so you took this 3 by the x and said that one minus 5.
With the x, yes, the x has got the 3 minus the minus 5, the y's got the 4 minus 3.
Okay, cool. I'm with you now, yes.
The last one is the z. Now, even though this z looks like it doesn't have a power, it does have a power. The power is 1, but we never write the power 1 because it's just assumed that it's there.
Okay.
And even though it's just a 1, it's still bigger than minus 2 because a positive number is always bigger than a negative number. So even the z's are going to stay at the top. So I'm going to have z to the 1. I'll now write the 1 because now I've got to subtract that minus 2 from something. And then I'm going to say 1 minus minus 2. So I'm taking the 1.
So why is it, I just want to ask, why is it over 2? The 1, why is it over 2?
Oh, that's the 2 that was always there from the beginning. Remember when we divided the 4 over 8? So we took our 4 over 8 and we said that equals the same as 1 over 2. So that 2 at the bottom is from the coefficients, from the big numbers that were in front.
Oh, okay.
I'm now going to do all the minusing. And like I said, some of the minusing is actually going to turn into plussing. So,
Okay.
all I have left at the bottom now is the 2. There's nothing else. The 2's been left by himself. All on his own lonesome because all of my letters went up. 3 minus 5. So if I have a 3 minus minus 5, remember I said a minus and a minus makes a plus. That becomes 3 plus 5, which is 8. So I've now got x to the power 8. Looking at
plus 5 gives you 8. Yeah.
Looking at the y's is much easier. That's just 4 minus 3. I know 4 minus 3 is 1, but remember we don't write the power 1. So we're just going to write it as y.
Okay.
Then
so what about the 4 now?
We subtracted 3 from it. So we said 4 minus 3 equals 1. And then I don't write a power of 1, I just leave it.
Okay, so xy
leaves me only with the z. The z, remember, the powers of the z were 1 minus minus 2. And remember, minus and a minus make a plus. And 1 plus 2 is 3. So my z is now to the power 3. And can you see why I said this was quite a nasty one in the exam? Because it's a lot of steps.
It is, yeah.
The last step now is this. I'm just going to rub out the working out on the side. The last step is this pesky little 2 that's hanging around outside the bracket, because that's a power of 2. So I'm still raising a power to a power. Remember we said if we raise a power to a power, we multiply the powers. So to bring that 2 into the bracket, the 2 that's outside there, to bring it into the bracket, I'm going to have to multiply it by the power. So I'm going to have to say 2 times 8 for my powers of x. Y, I'm just going to put a 1 times 2. You don't have to. You can just stick the 2 above the y because 1 times 2 is 2. But that's just to remind me that 1 does have a power of 1. We just never write the 1.
Exactly.
And then the z was to the power of 3, so it'll be 2 times 3. Do you see how the power has to be distributed to everything inside the bracket? So that power outside the bracket, I have to...
Wait, just quickly go over that again. So I just want to write that down. So the x, y, and z, and then over that you said 2 times 8, 1 times 2, and 2 times 5. So
3, no, 2 times 3. So what I did is I took that 2, I multiplied it by the 8, I multiplied it by the invisible 1 above the y, and I multiplied it by the 3.
Okay.
So then I've got the 2 times 8, 1 times 2, 2 times 3. But I also have to take that 2 and I have to square that 2 over there. So I've also got to write that the 2 at the bottom is also squared.
Okay.
Happy with that?
I'm happy with that.
Then I'm going to just do those easy multiplications. So x to the 2 times 8 is 16. Y to the 1 times 2 is just 2. Z to the 2 times 3 is just 6 over, and 2 squared is 2 times 2, which is just 4. And then that is my final answer.
Okay. Okay, that makes sense. I understand that. So the final answer is then 4.
And that's about as difficult as they're going to make your algebra.
Okay.
If I look at past papers, I don't see anything more difficult than that. They do sometimes, though, like remember here we did, where was that one where we did the multiplying into the bracket? We were doing some multiplication where we multiplied a number into a bracket. They sometimes want you to reverse that. They'll give you the 3x plus 12 and they'll tell you to factorize it. So when they tell you to factorize something, if they say factorize, you've got to look at what the common factor is of whatever they've given you. So they might say factorize, say 5x plus 20, if that was a nice easy one. Well, looking at that, I've got a 5 and a 20. I know I can divide both of those by 5. So I know that a common factor of that would be 5. I can divide that by 5 and I can divide that by 5. But what I have to do is whatever I'm dividing it by, I have to write outside the bracket. I can't just divide by... I can't just go and divide everything by 5 because that'll change the whole value of everything. So to factorize it would give me 5. 5 divided by 5, that's 1, so the 5's cancel out. And I'm left with x plus 20 divided by 5. Well, 20 divided by 5 I know is 4, because 5 goes 4 times into 20. So that will be that number factorized.
Was that a plus or a times?
Oh, that's a plus.
Is it a plus?
Yeah, sorry, my second one doesn't look like a very good plus, does it? So that's a plus. And don't let them scare you by making it longer, because it's still exactly the same thing. So even if they give you like a whole bunch of terms, like if they said something like 18z to the power 3 plus 9z to the power 2 plus 6z plus 12, let's just say. And then they say factorize that. So even if they give you something that looks scary, it's not scary, it's the same thing, it's just they've made it longer. So again, I've got to look for a common factor, something that goes into 18. Now, forget the letters, because they all got different powers, and there is no z on the 12, so I can't divide any letters out. But I can divide everything by 3, because 3 goes into 18, 3 goes into 9, 3 goes into 6, and 3 goes into 12. But whatever I'm dividing by, remember, I do still need to put outside the bracket. So if I'm dividing by 3, I stick a 3 outside the bracket, and then I divide everything through by 3. And then I'm going to get an answer of, I start with the number outside the bracket, the 3 that I stuck outside. 18 divided by 3 is 6z to the power 3. Like I said, the variables aren't going to change. 9 divided by 3 is 3z squared, minus 6 divided by 3 is 2z, plus 12 divided by 3 is 4. That now, Annie, is factorized. I can't factorize it any further because there's nothing that goes into 6, 3, 2, and 4. And at the same time, I can't factorize the z's because I don't have a z on the 4. I have a z on the 6, on the 3, and the 2, but not on the 4. We've covered a lot today. I will send you the video because it's a lot to take in one lesson. What we haven't done yet on algebra, because algebra is quite a big section, I haven't done equations, inequalities, and functions. I haven't done those yet. So we're going to have to do some of those as well. I think your phone's frozen.